Well, hello guys, and welcome back to Mr. G Physics. Here's Mr. G, and this time we're going to be solving another question from this momentum and impulse, the consolidation material. If you didn't subscribe for the channel so you can get all notifications and videos I post on regular basis. I see you. So we are back here to the consolidation material, and this time we are going to be solving a question 3. So this question 3, it was it was done in one of the question papers previously, and the question says the following. The diagram below shows two trolleys P and Q that held together by means of a compressed spring of the flat frictionless horizontal. Guys, this one is like the tracks that you did for the experiment. The mass of P and Q are 400 grams and 600 grams respectively. You know what we can convert? Remember to convert, you divide by 1,000. So I'm going to write it here just in case somebody don't remember. This one is 400 divided by 1,000. This is equal to 0.4 kilograms. This one is 600 divided by 1,000. That is equal to 0.6 kilograms. That is how to convert, and that is the first part. When the trolleys are released, it takes 0.3 seconds for the spring to unwind to its natural length. The trolley Q then moves to the right at 4 meters per second. Initially, both of them are at rest. So that is important to note. State the principle of conservation of linear momentum in words, and then you have to do few calculations here. So let's take the principle before we go to the rest of the question. So let's do the definition here. This one is question 3.1 here. All right, the total linear momentum in an isolated system remains constant. Guys, 2 marks for that. Remember, you cannot mess the word total and isolated system. If you forget those, you are not going to get the mark. So please don't forget those different words. All right. So the next one say calculate the velocity of trolley P after the trolley has released. To do that, let's as usual really fast. We cannot take like forever doing this. We are going to write the data. This is question 3.2.1, and then we're going to write data. Now, in this case, we're going to take write as positive. I always try to do it in the data so I don't make mistakes with the substitution. Now, M1 is equal to 0.4 kilograms. We're going to check just now. M2 is equal to 0.6 kilograms, if I'm not mistaken, 4 and 6. Okay, we have P and Q. So instead of 1 and 2, we can say P and Q rather here. So this one is P, this one is Q. That is given to you. It's not a problem there. The initial velocity of P is equal to the initial velocity of Q, and they are equal to 0. They are at rest initially. Now, after, or this one is before the collision of that specific explosion. After, we have that the velocity initial of P, that is what you are looking for. Yes, that is what you are looking for is question mark, and then the initial velocity of Q is equal to, is given to you guys, 4 meters per second. We say right is positive, so it's going to be a positive 1. 4 meters per second positive. The rest is to use the law of conservation of momentum. And remember, I told you to start from this point. MP, initial velocity P, plus MQ, initial velocity Q. Let's go to use vector notation is equal to MP, final velocity P, plus MQ, final velocity Q. And guys, the rest is to substitute. So here we have that is 0.4 multiplied by 0 plus 0.6 multiplied by 0. This is equal to 0.4. The initial velocity of p, what you're looking for, stays like that. And then for the next one is 0.6 multiplied by 4, which is the initial velocity positive there. So this one is to calculate, all this is 0 on the left hand side, and then this one is 0 equal to 0.4 final velocity p plus, and then this is simple calculation. Let's do it anyway. 0.6 times 4. Guys, I do all calculations before, but I want to make sure anyway. So this one is 2.4. So now the velocity, the final velocity p is equal to negative 2.4 divided by 0.4. Step by step, in case somebody have a problem there. So now here, when you divide by 0.4, you get 6. So the final velocity p is equal to negative 6 meters per second. The question asks you to calculate the velocity, which means you need a direction. The negative means direction, but we're going to write it in what? We're going to keep doing it like that, because I've seen in exams, while I'm marking exams, that they don't want to give marks if you don't write the word. So let's say the final velocity p is equal to 6 meters per second left. And that is the final answer. Marking wise, they gave you in this specific question 4 marks. So it's 1 mark for applying the law, 1 mark for the substitution on the left hand side, 1 mark for the substitution on the right hand side, 1 mark for the final answer. If the direction is not there, you do not get the mark. Now, the next question is, I calculate the magnitude of the average force exerted by the spring on trolley Q. So we have to use the data for trolley Q, guys. So that is important to have in mind here. So for this one, we are going to use Newton's second law in terms of momentum. This one is question 3 of my soul. This is question 3.2.2. All right, so we have all the data here. The only data we did not include is the time, which is given to us and is 0.3 seconds. So in this question, the time is 0.3 seconds. Now, remember, we're working for Q, so that is important to know. This is F net multiplied by the time is equal to mass, change in momentum, mass, final velocity minus initial velocity. That one is the change in momentum. All right, and guys, the rest is to substitute. This one is for Q. So F net multiplied by 0.3 is equal to mass. Mass of Q is 0.6. So it's 0.6 multiplied by a final velocity of Q is 4 positive, 4 positive. The initial was 0, starting from 0. And guys, it's a simple calculation. F net is equal to, when you calculate, I'm going to redo the calculation, 0.6 times 4 divided by 0.3, you get that is 8 Newton. Now, once more, let's make sure we answer the correct question. Say calculate the magnitude. So magnitude means no direction. So the final answer is like that. F net is equal to 8 Newton. That is the final answer for this question. They gave this time 4 marks, and it's going to be similar to what we did before. 1 for the formula, 1 for the substitution on the left hand side, 1 for the substitution on the right hand side, and 1 for the final answer. And then the last question is say, is this an elastic or inelastic collision? Only say yes or no. Guys, if you are not sure, you can do the calculation. So you can calculate the total kinetic energy initial and the total kinetic energy final. But it's very simple, because initially they are at rest. So the total kinetic initial, kinetic energy total initial is equal to 0, because they were not moving. The speed was 0. So that's it, something important. And the total kinetic final is something that is not 0, because they are moving. So the collision is inelastic. And that's it. Without calculation, it's quite simple for this specific question. Guys, thank you for watching. I hope it helped. If it helped, thumb up, subscribe for the channel, and I'll see you next time with more questions from this material, Mr. G. Yeah.